Alrighty, hello Math 806 students, Mr. Roseville here, and we're going to be reviewing factoring polynomials. One of the things that we need to remember is we're basically going backwards from multiplication. So if we recall, these over here, these are my factors, this is also a factor, and at the end you have the product, and it's what we get when we multiply them. And that's one of the main things that we're going to be talking about here. And so we know that when we take a factor times a factor, we're going to get our product. And what we're going to be working on is going in reverse, is we're going to get a product from the factors and factors. In this case, we have 3 times 5, and that gives us our 15. Okay? The main idea outline over here. If we recall this picture over here, we have the following polynomial being multiplied, and this is really the important piece. If you notice, it breaks this up, this dotted line breaks this up into 4 regions, right? So the first region here, I have x squared, x squared, x squared, so that gives me 3x squared. The second region here, I have 8x, okay? And then another region here, I have 2x. And the last region gives me plus 8. And if I add it together, I have 3x squared plus 10x plus 8. And so where am I going with this? The whole purpose behind this is eventually what we're going to do is we're going to group these in some kind of a way. Notice I just applied a parentheses, okay? And notice they have something in common here. We're going to deal with this later on, but just as a little idea here. And no, this isn't working. Anyways, ignore that part. Something we'll eventually get to. Okay, and this is basically what this talks about. Over here we have our factors of 3x squared, 12x, 2x, and 8. And we get our larger region. So if you notice, the geometric shape of each of the 4 regions is a whole rectangle. Again, we have that whole rectangle idea. Okay? Look at each of the 4 regions, one by one. Is there's a variety of different types of objects in each region, or are they all the same type? So they are the same type of shape. So what it means is all of these in here, they're all the same kinds of shapes. Okay? Over here, it says some vocabulary. The single quantity 3x plus 2, which is contained in parentheses, has 2 terms. The terms are 3x and 2. What are the terms contained in the quantity x plus 4? That is x and 4. Why are these called terms? Because they are just polynomials, i.e., so these are polynomials here, and so the things in polynomials are called terms. And when I say the they, I'm referring to these ones over here, x plus 4. The product 3x plus 2 times x plus 4 has 2 factors. They are, i.e., this factor and this factor. They're just 3x plus 2 and then x plus 4. Why are these called factors? Because they multiply to some product. Okay? So this one over here, I'm going to have you kind of fill in. So if you notice over here, we're going to be distributing something. So we're going to be distributing the 3x plus 2 and then the 3x plus 2 here. Okay? And we use some type of distribution, blank distribution. Was it left or right? You fill it in. When we multiply it over here, we're going to get 3x squared plus 2x. Over here, we're going to get 12x plus 8. And then that is blank distribution. Again, you figure it out. Okay? Nextly, we have that. And then finally, what we do is we get 3x squared plus 14x plus 8, and that is just simplifying. Specifically, we are just adding. Okay? Okay. So if we were over here, now think in reverse. Before you combine the like terms to get 14x, what two terms did we have? We had 2x and 12x here. So describe in a couple of sentences where those two terms came from. How were they produced? Well, what were they produced by? How did we get these guys? They were produced, because it says produced, from distributing what? X times 2 and 3x times 4. So basically we're referring to these steps over here. Okay? And over here it kind of talks about the same idea. So, and again, the goal is we're going to be just going backwards here. Okay? So there's just a little bit of background information. We need to recall the greatest common factor. If you remember, the greatest common factor is the factor, the largest one that they both, two numbers or two terms have in common. Okay? So if we remember making our tree, right? So if we're looking at over here, 18 and 24, we break them down to their prime factors here. And why does this help us? Well, we can find our greatest common factor. If we remember, we can do this two ways. We can either list them out. So if we remember, we know that 18 is 2 times 3 times 3, and 24 is 2 times 2 times 2 times 3. Notice they have 2's and a 3 in common. So the GCF is going to be 2 times 3, which is 6. Or you can do this with our Venn diagram. Nope. 3 times 2 times 3 is 18. 2 times 3 times 2 times 2 is 24. And the number in the middle is the GCF, which is, again, 2 times 3, which is 6, which is what this says over here. Okay? And the list method is what I did right over here. That's just a little bit of review on GCF. Page number 5. Continuing the Venn diagram, this can be done with 3 pictures as well. 3 numbers. So again, you have to first find your prime factorizations with a tree. Okay? But assuming this work is already done, notice 60 is 2 times 3 times 5. 45 is 3 times 3 times 5. 150, 2 times 3 times 5 times 5. And now we just circle. What do they all have in common? Well, they all have a 3. Oh, that was a weird circle. Okay. And what else? They all have a 5. Anything else? I don't think so. So the GCF of 60, 45, and 150 is 3 times 5, which is 15. Okay? You could also do this again with the Venn diagram. If you notice, you put the items, you write out their factors and put all the common ones in the middle. Again, the GCF is what they have in common in the middle, and it's going to be 15 again. Okay? And the list method is what I did over here. All right. So you can also find the GCF of monomials. Okay? So what we do is, again, we find the prime factorizations of these guys. X squared y cubed is here. X to the 4th y squared z is over here. If I were to list these out, I'm going to put this list right under here. So it's going to be x squared y cubed. So x times x, y. And we circle. What do they have in common? X is, how many y's? 1, 2. And looks like that's it. So then the GCF of x squared y cubed, comma, x to the 4th y squared z is going to be how many? I had 2 x's. That's x times y. And, oh, there's 2 y's times y. So it's going to be x squared y squared is my GCF. Okay? And if you notice, you could also do this with our Venn diagram here as written. Okay? And it's exactly the same thing here. Notice the list method is what I had there. Okay? That's the GCF. Oh, I forgot to answer. So give 4 examples of very different monomials. So what's an example? 5 is an example. How about negative x squared? What else? X y, negative 4xy, and you can just go crazy, right? P's or something like that, right? You can go make all kinds of ones, okay? Page number 7. Examples with GCF. So notice these can kind of get really ugly really quickly, right? So we have this really ugly problem. And how you attack them is the same way. You make a factor tree, right? You break these down to their prime factors. Notice it's done over here, okay? And so you figure out what they all have in common. Well, what do they have in common? Well, you kind of have to write all their factors out, okay? Kind of gets annoying, okay? But anyways, so how many copies of x, if you look at the questions, consider the variable x, how many copies of x are common to all monomials? So if you see here, what we have is the first one, there's 5 x's here, there's 6 here, there's 5 here. The smallest number is x to the 5, okay? And the y's, there's 7, there's 2, and there's 2, so the smallest number is 2. And then z, there's 3 z's, there's 8, and there's 3, so z cubed is the smallest number, all right? So then you just figure out the numbers that they have in common, or the coefficient factors that they have in common. So what are those? Well, how many? This is 2. Well, let's write them out. This is 2 times 3 times 3 times 3 times 5. This one is 3 times 3 times 5 times 5 times 5. This one is negative 1 times 3 times 3 times 5. They all have a 3's, 2 3's, and 1 5. So therefore, the GCF is going to be what they all have in common. They had a 3, they all had 1 3, they all had another 3, and they all had another 5, and then they all had an x squared, x to the 5th, y squared, and z cubed. So the GCF is going to be, what is that? 9 times 5 is 45, x to the 5th, y squared, z cubed. Okay? That's my answer here. Okay, so I'm going to set these up. You guys finish them off. So let's write them out. So 16 is what? That's 2 times 2 times 2 times 2. There's 1s. There are, oh, that's okay. Lights went out. There are 3 t's times t, and there's 8 u's. U, 2, 3, 4, 5, 6, 7, 8. And then underneath 36, how many is that? That is 2 times 2 times 3 times 3. There's 5 s's, okay? S. There's 4 t's, t. There's 1 u. They all have a 2. What else? 1 s. And how many t's? 1, 2, oops, looks like a third one here. Kind of messed that up, sorry. But we could see the GCF is going to be what? 1, 2, another 2, another 5. How many t's? It's messed up, but you can see there should be 3 t's, 1 u, right? And, oh, sorry, this isn't a 5, that's an s. So then what do we get? That's 4 times s t cubed u. And that's the GCF. Okay? You guys do this one. All right. Factoring polynomials, the GCF from a polynomial. And we've already done this. Note over here, we want to build these out. We should know how. So we want to find the factors that make this up. So if you notice here, I'm going to build this in the center. I have 3 of these guys here. So we have 3 of these guys. How's this going to go, right? So I have 3 here, right? And then I have 6 of these. So I can break those up evenly into 2 here, 2 here, and 2 here. Okay? So what that tells me then is that this is x, 1, 1. Therefore, this is equal to x plus 2, and this is 3x. So hence, what we get is going to be x plus 2 times 3x. All right. And that's kind of... so what does this mean? So in this case, this over here, this value, because it's a monomial, this is going to be our GCF. So what does this mean? i.e., the GCF of this polynomial, and that is going to be the 3x, okay? Anyways, this is just a nice little introduction, okay? We remember doing this. We're going to practice taking this value out over here. It's the greatest common factor, okay? Okay. So we're going to factor polynomials using generic rectangles. So this has two terms. They're 3x squared and 6x. We're going to put each of these terms in their own rectangle. So that means we have 3x squared and 6x. I'm trying to factor this polynomial, so rewrite each of these terms, but present them fully factored. Okay? So this is going to be 3 times x, and then 3 times 2 times x. Okay? Now we're going to see the GCF of these two terms. Well, what is it? What do they have in common? They have a 3, what else? And they have an x, right? Write that factor, 3x, to the left of the rectangle. So we're going to do that. And then for that first term, 3x squared, when you factor out 3x, what's left? So if I were to take out, if I put 3x here and I take it out of here, I just have x, right? And the same thing over here. If I take out 3 and x, I have 2, okay? And so that you know that that's just x plus 2 is what's left over. And that gives you the inside. And the same thing here, that's what it says. When you factor 3x out of the 6x, you got a 2 left over. And so basically we have this image here. And that's kind of similar to what we did up here. All right? Okay. Okay, we're going to go ahead and move on. This we'll talk about in class. Okay? Number 11, page 11. So for the example number 7, we're just going to, if you remember going over this algebraically, we're going to factor this polynomial algebraically. So what you do is you decompose this. That's 3 times x plus 2 times 3 times x. And if you notice here, what do they all have in common? They have a 3x. You take it out. So it's 3x. And what's left over? X plus 2, which is what we have here. Okay. So the first one is the given. Next is decomposing. Next property is the commutative property of multiplication. And then the next is distributive property. Kind of distributing in reverse, right? That's okay. Again, so with factoring this polynomial, you always want to take out first the GCF. Okay, that's really the name of the game here. So what is the GCF? Well, we could do this a few different ways, right? If we decompose this, we could do 3 times x minus 6 is 3 times 2 times x, that's 6x. 9 is 3 times 3. And if you notice here, what do they all have in common? They have a what? They have a 3. So we take it out, and you're left with 3 times x squared minus x, 2x plus 3, and that's your factored polynomial. In the same sense, we could do the following. Notice I have 3 terms here. You can write them in these boxes. You factor each one. And the GCF, and again, this is just another way to visualize it. You can do it both ways. They both have a what? Everybody has a 3. So they have a 3. And when we factor out the 3, what's left in the first one? X squared. The second one, negative 2x. And the third one, 3. Hence, what we get over here, which is what we wanted, which is what we had here. Okay? Page number 12, we have factoring the polynomial using algebra. And again, we already did this on the other page. So we have our given. This is decomposing. This over here is using the commutative property of multiplication. And finally, we are using the distributive property. And again, you are distributing even though you're doing it in reverse. That's totally okay. Example number 9, we will do in class, because we need tiles for that. Need some tiles. Okay, for this classwork here, you're going to use a factor tree to factor the coefficients. Okay, so you're going to make a tree to factor the coefficients of this one. So you're going to do is your tree should, I'll start you off. That's one of your trees. That's one of your branches. There's the other one. And then it's your other one. Okay? And then when you're done, you're going to find the GCF. Let's just say it's going to be blah. Okay? And then you're going to take out, when you're done, you're going to write out what they all have and then take out the GCF. Okay? And just another way to do this, I mean, it says with a factor tree, but you could also do this by decomposing. But actually, B will let you do that. It says factor this using generic rectangles. So in other words, what you need to do, you need to create 3 boxes here, put each one in there, and then factor it. What is that? How do you know what goes in here? That's from up here, right? I'll do the first one for you. What is that going to be? 2 times 2 times 2 times 3, x, x, y, right? And you do this one. And then your final one should be the answer here. It should be what's numbers, values here. It should be something here. And then what's left in here should be the final one. And then this one, we're going to use algebra. If you're curious, the algebra model is just here. That's what we did here. Okay? All right. And number 14 we will do later on. Okay? That's it. Thanks a lot, everybody. And email me if you have any questions.